Hello, here is my report for Module 1. I'm going to share my Excel spreadsheet with you. Here we are. Let's start with number 1. Okay, I found the quantum foam to be the most profound because of how small it is. It is the foundation of the fabric of the universe. And if you look right here, you can see the size of it is 10 to the negative 35th power. This information right here shows how fast you would be moving if you were standing still on the equator. You can see that you must take into consideration that we are on a moving planet that is in a moving universe, so that when you are standing still, this is how fast you're actually moving right here. These speeds are all relative to something and are not directly measurable. As we saw on the scale of the universe, everything was relative to the starting point of 1 meter and could progress either way in comparison. Large numbers and small numbers both can be very long, and we shorten these by using scientific notation. E is another way to write scientific notation and can be positive and negative. Okay, number 2. These graphs show misleading information. Someone may want to report misleading information, so their audience may lean towards one stance or another. As you can see, when the set point of the y-axis is not set at 0, the bar graph relative to it looks misleading. When we entered the information from the misleading Terra chart down here, we see that their portion is a lot smaller right here than their chart suggests. Using the formula for area and dividing, we found their portion of the original chart is taking up almost 14% of the chart. Data can also give misleading information depending on the way it's collected. There can be sampling bias, questionnaire flaws, and effects caused by the interviewer. After inputting this information into our own graphs and charts, I see that I really need to look at the numbers instead of the pictures representing them to get the real story they are telling. Moving on to number 3. Okay. Says these samples right here of data include all Americans and then Americans with one or all 3 elements of obesity, high blood pressure, and type 2 diabetes. Some of the numbers are whole and some are in percent, right here. To sort the data, we created charts with the information we had, and we filled in the blanks for the information that we did not have, so that we could complete our Venn diagram. The probability of being obese and not having the other 2 elements is 3.1%. So that's this circle right here. But the probability of having all 3 is 8.5%, which was overlapped by all 3 circles in the middle. So it's almost half as likely if you're obese that you'll have all 3 ailments. High blood pressure has the highest probability on its own. So if you're obese with high blood pressure, you would be in the highest percent of Americans right here. The results would be different if broken down by state. Colorado has the lowest percent of obesity, which makes you less likely to have all 3, as compared to Arkansas, which is one of the highest. The result by state for high blood pressure shows that Arkansas is equal to that of obesity, but Utah has the least likely rate of high blood pressure. Moving on to number 4. Okay, we have charts that compare the height in inches of Army recruits, and then we have 2 charts that compare the height in inches of random mall shoppers. You can see in the scatter charts here that the Army recruits are more similar in size by the tightness of the data point compared to the random mall shoppers, which are more spread out. The standard deviation of the Army recruits is only 4 inches right here, while the mall shoppers is 14 inches. That is quite a big difference as seen against the trend line. It is the same with the coefficient of variation. It is also much smaller than the Army recruits. I'm sorry, in the Army recruits. This coefficient is a smaller number than the mall shoppers. If you look at the same information put into a box and whisker chart, the wider box here shows a larger deviation of height. A likely reason for this difference is the variety of gender and age in the random mall shoppers, while the Army recruits are most likely all male and have more similar height. Okay. Number 5. This information shows the average number of sleep hours of Duke scholars. The mean or average is 6.7 hours right here, and it's shown in the chart right here. The standard deviation is 2.03, which shows the difference in hours between the scholars, which will also affect the shape of our curve right here. The percentages on the charts show the probability of someone falling into that section on the chart. So I usually sleep 8 hours a night, so I fall here in part of the higher percent. Now on the next chart, we see distribution of the average American income. Since the median income is not close to the mean, we have a chart that is skewed to the right. This is because more Americans have a higher income than the middle of the chart and is not normally distributed with a standard measure of differences of income. Number 6. Okay, this chart shows the profit of sales of flamethrowers. The initial investment or output right here of $12,000 is shown at the top of the chart where no sales have been made. We can see that at 100 sales, it is the lowest number we have for profits, which is the bottom line right here. And after that, we start gradually going up. The break-even point happens between, 200 and 220 sales. 1 second. And the numbers start to go into the positive from the negative. Elon must sell about 260 flamethrowers to profit $90,000, and that's shown right here at 260 flamethrowers. From the chart, you can see that starting a business can be a financial roller coaster. After the initial investment, the numbers must continue to go into the negative until the After the initial investment, the numbers continue to go into the negative until the break-even point, and most people do give up before that point is reached. That concludes my report on all the information in the Excel spreadsheet.